The third lecture in Chapter 5 studies a type of variance that we're going to use often called standard deviation. It's measuring how deviant or different my data is from the mean. So it is technically the average distance the data is, or the values are, away from my arithmetic mean x bar. So it's a type of variation that we're going to use often in the course. So you want to get a good grasp on this. So make sure you reread the section and look for some other resources if need be. The standard deviation of 0 means there is no deviation. The average distance is 0. So if I'm 0 units away from x bar, I must be at x bar. So what that's saying is all values are equal. Now this doesn't happen very often. We wouldn't have interesting data. We have data that's interesting because it has variation. It has a standard deviation to it. Extreme values. What do they do to my standard deviation? Well, if I am sitting at x bar, we'll just pretend x bar is there, and I have this extreme value out here, if you look at that distance, the average distance away from x bar, it's large. It's going to increase. So extreme values increase the distance that I am away from x bar, thus increasing standard deviation. We're going to abbreviate standard deviation with an S and a D, so we don't have to write that out the entire time. S and D stand for standard deviation. Now, just like in measures of center, we have a standard deviation that comes from a sample, and in theory, one that could come from the population, even though we'll never likely get to see the entire population. So the symbols for the sample, standard deviation, is a symbol S. Now, I like to use a script S because my S here looks almost like a 5, and we call that S a statistic. In my population, my symbol for the standard deviation of population is a circle with a line called sigma. And that comes from a population, so it's called a parameter. And what we need to realize about standard deviation is that we'll always be greater than or equal to 0. We'll never have a negative standard deviation because we can never have a negative distance. So we are, after this next problem, going to always calculate standard deviation using technology. The TI-83 is a very nice tool to calculate standard deviation. We will show you a lecture after this using the calculator. If you don't have a calculator, I have a link set up in the website underneath Chapter 5, Finding Standard Deviation, that you'll want to use for the next few chapters. So finding standard deviation by hand. The first thing is, if we're looking average distance from x bar, I need to find x bar. Totaling these up, dividing by how many are in my set, how many observations I have, I see that x bar is 4. Now when you calculate distance, distance is always positive. So if I take 0 minus 4, that's going to give me a negative number. To make it positive, I'm going to square it. To that, I'm going to add the distance that 5 is away from 4, and again square it to keep it positive. And lastly, 7 minus 4, again square it. Now when I total these up, I get 26. Now we're going to divide because it says average distance. We have 3 data points that I need to take 26 units and divide them amongst. Now because of theoretical reasons called degrees of freedom, I have to divide by 2. It is n minus 1, one less than it's in my sample. I know that seems strange. There's some theoretical reasons for doing that. When we're dealing with samples, we're going to divide by 1 less that's what's in my sample size. When I divide 26 by 2, I get 13. Now, we know the average distance isn't 13 away from 4. 7's not even close to being 13 away from 4. But if you recall, I had to take this square up here to make my distance positive. So to undo a square, I take a square root. So you're showing that on the calculator. The square root of 13, if I wanted to know the approximate value of that, I would take the square root, which on this calculator is second x squared, type in 13, and I would get 3.6. So on average, I have values that are 3.6, a distance of 3.6 away from my value 4 or my mean. Again, I'll show you how to use a calculator in more detail in the next lecture. A large standard deviation, what does that mean? It means that it's more variable. In other words, it's more spread out. There's greater distances between the mean. A small standard deviation just means that the data values or observations are close to the mean. The average distance is small. Now, when we look at standard deviation, we want to think of standard deviation, especially when we get into Chapter 6, as our yardstick. It's our measurement. It's our measurement tool to tell how spread out my data should be. How long should my distribution be? Should it be really short, or should my distribution be very spread out? And the standard deviation then tells that spread, and it shows up in the picture nicely. That's where we're headed in Chapter 6. A couple more things. Variance is the square of the standard deviation. We don't use it much in this class, but we need to know what's out there. It's S squared, or sigma squared. So if we took our last value where I had S is equal to the square root of 13, before I took the square root, I had S squared, and that was just equal to 13. And again, we'll show you where that appears on the calculator. So in summary, the symbols that you need to get out of this section that are going to be very important, and you need to have some sort of cheat sheet, a list of symbols and their meaning next to you when you do these problems, because when you read a statistical study or start doing statistic problems, it's not going to be a descriptive word, it's going to be a symbol. So back just to a review to the symbols that we need to make sure we know. The mean of the population is mu. The mean of the sample is x bar. The variance of the sample is S squared. The variance, the sample standard deviation is S. Notice these two go together. The variation of the population is sigma squared, and the population of the standard deviation is sigma. So make sure you understand populations have kind of a more formal symbol to them, where samples or statistics have kind of a general, like S versus sigma. So you want to make sure that you especially have these understood and know where they apply. So when you see the letter S, you're thinking the distance on average away from the mean of a sample, called sample standard deviation.